pump is running, pump is running. Somewhere the discharge, some valve is closed, the piping.
Yeah.
Pump is running, pump is pushing under the, again at the discharge closed outlet.
Okay.
Yeah. So in such case, does the inlet pressure at the pump suction pressure, will it go high to trip level, or it will keep pushing it to the discharge so that the suction pressure will not go high?
Okay. Okay. Yes. Okay. As a say point of the high suction pressure, what is
50 bar.
50 bar. Okay. So
the example, okay. One second. Let me clarify. We are the suction pressure at say example 45 bar. The pump is running. Yeah. It 50? Is developed 45 bar. Assume that 45 bar. Okay. 45 bar pump is running. Okay. Assume that generating around 135 as the discharge pressure. Just giving you. So some discharge valve closed. Pump is again running at the same this one. Will it assume that it is running the same this one? Will the suction pressure goes high suddenly to more than 50 bar, or it will be keep pushing the liquid to the discharge?
Okay. Based on we have already now a maximum output pressure of the pump. Okay, in case the suction pressure increased to 45, okay, up to 57 bar gauge. Okay, we consider what is can be called a clamping speed or limiting speed. I cannot go more than this speed. Okay, why? Because I have a restriction about the maximum output pressure. Okay, it's coming from where? Okay, I have the maximum suction pressure with 57 bar. This is now the current 57. Okay, and I have a maximum allowable pressure. If we deduct the maximum allowable pressure minus the maximum suction pressure, so it will give me the maximum differential head. This maximum differential head I consider like a shut-off head at a certain speed. This speed we will limit in the logic. Okay, once I get this maximum suction pressure, I cannot move up or reduce the speed beyond this limit. Okay, by this way I can maintain the mechanical integrity of the pump casing and for sure the mechanical seal cartridge.
Okay, forget all the safeguards, all the integrity, everything. You just forget. I mean, assume that no integrity, no safeguards available. Yeah, without any safeguard, without any trip functions. Yeah, we are talking because we evaluating the integrity requirement for that. Assume that no safeguard, no mechanical protection, nothing is there. The pump is running at some suction pressure and then discharging at certain pressure.
Okay.
Now the discharge some valve closed.
Okay.
Assume that no production available.
Okay.
And then does the suction pressure goes high or pump will keep, assume that the pump is running at the same speed. Okay. Pump will push the suction to this one, develop the discharge pressure. Suction pressure will not go higher, suction pressure will go high. That is the question.
Okay. Suction pressure is X value. Okay. Yeah. And then I somewhere or for any reason the FCV downstream the pump is closed. You mean like that?
Assume no other production. Pump is running in the same condition.
Okay, and the same condition without any control or protection. Okay, at this point, okay, if there is no protection, this means that the discharge pressure of the pump may exceed the maximum allowed pressure of the pump or the casing.
Okay, no,
and this will lead to the pump failure.
Okay, agree. But before that, does the suction pressure go high? Suction pressure will not go high, right? So because pump
will not go high. No, will not go high. Why? Because I suck the flow from the suction to the discharge, so it will not go high. It will reduce the suction at the same time. It will build up the pressure at downstream the pump.
No, but your shut-off head when you calculate, it adds your suction pressure.
It will be both of them. The suction pressure plus
discharge. Yes,
but it will be dynamical and then it will be.
No, I'm saying that what Ananta you are coming, I think from understand. If suction pressure is not increasing, it is the same. Then discharge pressure will
build up. Will be within the limit.
That's not go beyond
will be within the piping limit.
That's because discharge pressure has to add 60 bar of the suction to go beyond the.
But not only the pump will be failed, but also the piping downstream.
Yeah.
Because you know the
Yeah.
design pressure of the piping is less than
Yeah.
the maximum allowed pressure of the pump.
Yeah.
So this means that the failure coming on the piping first before the pump failure.
Because we are booking
So
the
shut-off height is actually the addition of maximum suction pressure plus the differential pressure which
Exactly.
pump can create.
Exactly.
If
Okay.
suction pressure is not increasing, then you will not see the discharge pressure more
Discharge
than
pressure will not go,
Yeah.
piping will not
Yeah.
rupture. That's what we're
Yeah.
doing. Okay, fine.
Yeah. So guys, I think we are on the same page. Of course, when the discharge pressure is a blocked outlet case, so pump suction will see the high pressure, and this we have taken the credit accordingly, and we are happy. Now we are going for the last shift.
Can we go to the worksheet, Chairman?
Yeah.
Okay, one second. Okay.
So
The pump on high suction pressure. Okay.
yes. So this is correct, guys. So
Why we consider two times that 203? Can you go to right?
no, this is for first course. This is for first course.
Second, yeah.
This is for
Okay,
second course.
second class, yeah. Okay.
First is money.
Guys,